Hey guys, so today we're going to do some solving of real world polynomial problems. So we're going to look at where do polynomials actually occur in some real life situations. We're going to do some graphing using Desmos. I hope you're getting used to using it. It's actually a really good app and I love to use it. It's great for this course and saves a lot of time with the graphing. And then we're going to look at what happens in real world problems based on like what does the domain need to be, because when you start to get into polynomials in the real world there are restrictions, and a lot of the times parts of the graph don't actually come into play because it's not realistic, which we're going to see. I'll show you in this problem and you'll kind of get the idea of where it works and where it doesn't work. So we can use our knowledge of polynomial functions so far and the key concepts to help us solve real world polynomials using their graphs. We're not doing anything algebraically yet, so we're just going to base it on graphs today and what we get from them. So the best way to see it, or the best way to go through it, is to go through an example, and I'll give you some tips and whatnot to think about using this example. And there's lots of practice questions that I've given you guys, and then of course the quiz. So in this example, forces acting on a horizontal support beam in a garage cause it to sag by d centimeters, x meters from one end of the beam. So it means that we're going to have a beam and it's going to cause it to go down, which is going to make it sag a little. The relationship between d and x can be represented by the polynomial function, and here it is. Here's our equation. D of x equals 1 over 1800 times 950x minus 22x cubed plus x to the exponent 4. Graph the function using technology. That's the first thing you kind of want to do with most of these. And I've done that, so I'm just going to show you what I got for it. So here it is. I graphed the function using Desmos, and I've imported it in so you can see what I have. And then also on the screen it shows you much more, but I've just showed us what we actually need. So here's a graph of it. You can see it starts at 0 and it intersects again at about 8.5. So B says determine the domain over which the function models the relationship between d and x. What do you think causes the restriction on the domain? So in this case, because we're thinking about how much it sags, it makes sense that it's only going to be a positive value, and it's not going to be negative because it's not going to sag in a negative direction. And it's also, so that takes away all of the negative parts, which is why I only showed you from here to here, but we can actually make it smaller. The domain is set that x is in the set of real, so all the numbers, but it has to be between 0 and the biggest number is about 8.5. What do you think causes the restriction on the domain? In reality, we are not going to have negative distances in this case, which happens in a lot of different examples. C, determine the maximum deflection of the beam. So that's just looking at it. Where is our maximum point? And if I go back to my graph, I actually find that my maximum point if you click on it in Desmos, is I got this from Desmos. Just because this graph I've put here is a little bit harder to see. I just wanted you to see it so that you could judge if you did yours correctly. Is 1.4, sorry, I'll write it like this, max 1.4894, and it happens from the point, it happens at 4.437 distance. Oops, distance from the end of the beam. Okay, most of your questions are going to ask you to graph it and then come up with the different things based on what that graph is. Try your best. Look at the answer key when I've got it up there and try them. They're all kind of similar because it's just asking you to graph it and pull the information right from the graph. If you have any questions, let me know, and I'll see you guys later.